So right here, we see g of x equals negative 2/5 x. Wow, this is going to hit two birds with one stone. Watch this. It's going to do two things. One, when you have 2/5, 2/5 is going to flatten. It's going to make it less steep. But then the other thing that's going to happen is when we multiply by a negative, so it's compressed vertically and then reflected across the x. So it's flattened and then reflected across the x, right? So it's like this. Here's a ruler would help. It started out this steep, it's less steep, and then it reflects across the x, so it changes its slope. Okay? All right. Oh, I didn't finish with this. Hold on. There we go. So then that ends up being... Okay, it says, describe the dilation and reflection of g of x equals negative 2.75x squared as it relates to the parent function. Well, let's see. In the graph, the parent function is stretched vertically. We know that it's stretched vertically because that's 2.7. The absolute value of negative 2.75 is positive 2.75, and that's greater than 1. Then, what do we know? It's reflected in the x-axis because it's negative. So let's look and see what that would look like. Now, it's not going to move from the origin, so it couldn't be this one. And because it's reflected in the x-axis, it's going to flip upside down from the original. So this looks like it's multiplied by 2.75 because it should go through 1, 1. But notice, what does it go through instead? 2.75. That's how you know. And it should be flipped upside down, so we're going to say C. Boosh, look at that. Walk you through, and then we're going to go fill in some blanks on our paper, which you can do as like the general form of the function. G of x equals a times f of x minus h plus k, where f of x is the parent function. Each constraint in the equation affects the parent graph. The value of absolute a stretches or compresses the parent graph. When the value of a is negative, the graph is reflected across the x-axis. The value of h translates the parent graph left or right, and the value of k translates the parent graph up or down, and we can see that here. So the orange is when it's greater than 1, the a being multiplied, so it makes it steeper. The green is when it's between 0 and 1, a fraction or a decimal, and it makes it wider. When we have a negative, it reflects into the x-axis, okay? What does it flip? What does it do? Let's watch it happen. Yeah, there we go. Or wider. There we go. And this is watching it reflect into the x-axis, or across the x-axis. Yeah, there we go. And then down here, horizontal translations. Let's look at that. That's when h is greater than 0, and that's when h is less than 0. Now it appears opposite of that. Same right here. We'll just see that in action. Awesome. Picture's worth 1,000. Okay, looking right here, let's fill it in. So what did we just read? The value of a stretches or compresses the parent graph. When the value of a is negative, the graph is reflected across the x-axis. The value of h shifts the parent graph left or right, and the value of k shifts the graph up or down. And I want to look at this right here. Let's talk about it. We have g of x equals 2 times x minus 3 squared minus 5. A couple of things. It's going to take the original graph. It's going to make it go down 5. This says minus, we know it's going to go right 3. And it's going to take that 1, 1 spot, multiply it times 2, so it should be hitting, it should be going up 2 and over 1, right? So let's look. And it's positive, so it's still going to open up. So it should shift down 1, 2, 3, 4, 5 left, 1, 2, 3, so that's a possibility. Down 1, 2, not a possibility at all. Down 1, 2, 3, 4, 5 is good, but it should go left 3, not right 3. That's gone. Again, that goes right 3. That's gone. The only one possible is A. And look at that. It goes up 2 over 1, which is due to the multiplication by 2 and being stretched by a factor of 2. Finishing off with this page, says towers, guy wires are used to add stability to structures such as towers, ship masts, and wind turbines. Suppose the two guy wires of a cell phone tower can be modeled by the function g of x equals negative 1.43 times the absolute value of x plus 45, where x in meters is the distance from the tower and g of x is the height in meters. Describe how g of x relates to its parent function. Well, we see our a is negative 1.43, so it's going to stretch at 1.43, and it's going to reflect it across the x-axis because it's negative. Our h is 0 because nothing's being added. There's no minus h, and our k is 45. Boom. So it's a graph of the parent function, and it's reflected across the x-axis. We didn't leave you a lot of room there. It is stretched vertically, and it's translated 45 units up. Of course, that won't give way too much room, right? Yeah, there we go. So this last one right here. What type of function is this? Well, it's a v, so it's going to be absolute value. Well, the parent function looks like this. It goes diagonal this way, and it goes diagonal this way. Okay? Identify the translations. Well, let's see. It goes down 1, 2, 3, 4. So we know our, well, let's start off with this. Down 4, so minus 4, and it goes left 1, 2, 3, so that's going to be plus 3, right? So we're going to have, at the very least, and it's not reflected or anything, so it's going to be absolute value of x plus 3 minus 4. And then we're definitely multiplying it by something. But notice, we got wider, so it's going to be a fraction. And what is it going to be? It's going to be, it should be going through right here. That would be just our regular 1, right? But it's going to be divided by 2, 3. So that's going to be 1/3. 1/3 x plus 3 minus 4. I know I kind of did all the steps right there. But write an equation for the function. So the equation would be g of x equals 1/3 times x plus 3 minus 4. Now, another way you could have solved this, guys, is you could have said, hey, if g of x stands for y, and I know my y value right here, or right here where it crosses the y-axis is negative 3, I could say negative 3 equals some number a times the absolute value of, what's the value of x right here on the y-axis? Is 0 plus 3 minus 4. Okay, this is another way to figure it out. I know that's going to be absolute value of 3, so that's just going to end up being negative 3 equals a times absolute value. If that's 3, it's just going to be 3a minus 4. Add 4 to both sides, and I get that what? 1 equals 3a. Divide both sides by 3, and I get that a equals 1/3. That's another way to figure it out. I just kind of did it graphically, so there's an algebraic way as well. All right, guys, big lesson, good stuff. With that said, peace out.